Homework 13, the rational zero theorem, video 4. Even though this is only the 4th video, it's going to be the last one in this series. And I'll go ahead and warn you, I know the 3 previous videos have been kind of long. This one may be even longer, because look at the problem. Find all zeros of f of x equals 4x to the 4th power plus 16x to the 3rd power plus 3x to the 2nd power minus 4x minus 1. This is our first venture beyond 3rd degree polynomial functions, but it won't really change our approach. It will just mean it's longer to solve. I didn't set up the steps, but we're going to do the same steps we did before. So we're going to start by listing the possible rational zeros. I invite you to pause the video and see if you can set them up, and then get your final list that we're going to run through synthetic division. I'm going to go ahead and set them up. For the numerator, we need factors of the constant term. The constant term is -1. For the denominator, we need factors of the leading coefficient. The leading coefficient is 4. So we need to write the factors of 1 over the factors of 4. And don't forget the plus minus. Well, the factors of -1 are easy. There's only one positive number that divides into -1, and it's 1. I don't have to write negative because my negatives are taken care of here. Well, what about factors of 4? There are 3 of them, from least to greatest, 1, 2, and 4. So let's make our total list. Our over 1s are 1 and -1. Our over 2s are 1/2 and -1/2. And our over 4s are 1/4 and -1/4. So the good news is our list is fairly short. The bad news is it's 67% fractions and only 2 whole numbers. But there's our list of possible rational zeros. Did you get that list? Did you pause the video? You should have. Don't worry. I'll give you a chance again. Next, we need to find an actual zero. And the way that we do that is we set up a synthetic division problem. Let's go ahead and set up the top row. Let's see if I set it up correctly this time. 4, 16, 3, -4, and -1. Now I only have 6 possible box numbers, and I have to find one that gives me a remainder of 0. Let's try 1, because it will always be in the list, as will -1. Add up the first column to get 4. I might want to pause and see if we can do the synthetic division. Multiply by the box. 4 times 1 is 4. Add to get 20. 20 times 1 is 20. Add to get 23. I don't think this is going to work. 1 times 23 is 23. Yeah, it's not going to work. Add to get 19. 1 times 19 is 19. Yeah, it had no chance of getting all the way back down to 0. These numbers were getting too big for the negatives to bring them down. So 1 didn't work. I invite you to pause and try -1. Did you pause the video and try -1? Did you find out that it failed? Because it does. Great. Our only remaining candidates are fractions. Sometimes you just have to suck it up and deal with it. So in this case, we got to pick one of these 4 fractions. Let's use 1/2. I don't know why I erased the entire synthetic division problem. I still need the top row. 4, 16, 3, -4, -1. I jokingly say that this is going to be difficult because this is a fraction, but it's not. Especially because it's just 1/2. Multiplying by 1/2 just means you're taking half of something. So don't say times 1/2, say half of. Add the first column to get 4. Half of 4 is 2. Add this column to get 18. Half of 18 is 9. Add this column to get 12. Half of 12 is 6. Add this column to get 2. I'm liking the way this is turning out. Half of 2 is 1. Hooray! We found a good box number. So one actual 0 is 1/2. And if you wanted to, you could reconstruct its factor. Because remember, saying that 1/2 is a box number is the same as saying that x minus 1/2 is a factor. Now, that's a weird looking factor. It's not wrong. Normally, the factor that would have produced that solution is 2x minus 1, but we'll run with the x minus 1/2. Actually, we don't even need to do that, because if we're finding an actual 0, we found it. X equals 1/2 is one of our solutions. Hooray! And how do we find the remaining zeros? Well, remember that when you find a good synthetic division problem whose remainder is 0, you have two factors. One from the box number, but we already know the 0 it's going to give us, so I don't have to worry about that. And the other comes from the results of the synthetic division problem. So let's turn this back into a polynomial and solve it. Wait a minute. The original function was degree 4. The degree goes down by 1. This is going to be degree 3. 4x to the third power plus 18x to the second power plus 12x plus 2 is equal to 0. Now all we have to do is solve that. You see the problem? That's not quadratic. It's cubic, it's third degree. We don't have a cubic formula. One exists, look it up, and then you'll regret looking it up. So how do we solve this? Well, the same way we started this one, but now we have to start with that one. So now we have to start over. But, sorry. I told you this was going to be long and drawn out, but the reason should have been kind of apparent from the beginning. If we find a good synthetic division problem, we're going to knock this down from 4th degree to 3rd degree. But that's going to need to be dealt with to knock it down to 2nd degree. In general, you do enough synthetic division problems until you get it down to x squared. So if you start with x to the 4th, that means you have to go through this twice. Now there is one thing we can take advantage of here. Do you notice anything about all 4 of the coefficients? 4, 18, 12, and 2. They're all even. How can we capitalize on that? We can divide both sides of the equation by 2. The right side still stays 0. The left side you can split up into 4 fractions, but everything would just get cut in half. So 2x cubed plus 18x squared, nope, cut it in half, plus 9x squared plus 6x plus 1. What's the advantage of that? Well, if we're going to start over, we have to make a list of possible rational zeros again. Or do we? Maybe we can take advantage of this list. Remember, if there were rational zeros, they were in here all along. So let's see how we can take advantage of this list coupled with the problem that we're solving now. Well, these didn't work before, so we don't have to check them again. 1/2 did work, but that doesn't mean we can cross it out. It could have a multiplicity of 2 or greater and show up as a 0 multiple times. But there are some numbers that we can cross out now, because think about how we would set up the possible rational zeros for this. We would do factors of 1 over factors of 2. And that would be our new list of possible rational zeros. But if the denominator now has to be a factor of 2, then it can't be 4. In other words, this list would be plus or minus 1 over 1 and 2, and I can't make a 4th out of that. So even though I have to do this problem again, I can still recycle the original list of possible rational zeros. If they didn't work before, they don't work again, so no need to try 1 and -1. And because the leading coefficient got knocked down to 2, my denominator can't be 4 anymore, I can cross those out. So now all I have to do is try one of these. I did mention that 1/2 worked before and it could work again. So let's set up another synthetic division problem. Let's try 1/2 again. 2, 9, 6, 1. Now, we can run it through, but I'll tell you right now, it has no chance of working, and here's why. There's something else all these numbers have in common. Well, they used to all be even, we fixed that. They're all positive. Why does that matter? The box number is positive. So all of my moves are going to involve multiplying and adding positive numbers. And if all I'm doing is adding and multiplying positive numbers, there's no way they can add to give 0 at the end. If that's a little bit too deep of an analysis, then pretend it didn't happen and just run through the synthetic division. Just remember, times 1/2 is the same as 1/2 of. Add the first column to get 2, half of 2 is 1. Add that column to get 10, half of 10 is 5. Add that column to get 11, half of 11 is inconvenient. It's 5 1/2. It's a fraction, which is even worse because that's not a fraction. A whole number and a fraction can never cancel to make 0, but they're both positive. Just as a rule of thumb, if all the coefficients are positive, then your box number can't be, because your box number would just keep everything positive. All right, so 1/2 doesn't work again. It worked once, but it didn't work twice. And I'm telling you, just because a number works once doesn't mean it can't work again. So don't throw it away until it fails to work. Well, if that throws away 1/2, it leaves only one other number, it's -1/2. Now there's no guarantee -1/2 would work, except that I built the problem so that it will. If you're nice, I'll show you, well, I can't tell if you're nice. At the end of the video, if I remember, I'll show you the work I did to actually build this problem. All right, so let's run -1/2 through synthetic division, and multiplying by -1/2 means cut in half and change the sign. Add the first column to get 2, cut it in half, 1, change the sign, -1. Add, 9 and -1 is 8. Cut it in half to get 4, change the sign to get -4. Add to get 2, this is going to work. Cut in half to get 1, change the sign to get -1, 0, hooray. I found another 0, -1/2. But we're not done, because the bottom row now represents a new polynomial. We just did a synthetic division problem on a degree 3 polynomial. It lowers it down to degree 2. So this 2 represents 2x squared, and then plus 8x plus 2 is equal to 0. Good, now it's quadratic. But do you notice anything about the coefficients? They're all still even. Let's divide them all by 2 without actually writing divide by 2. This becomes x squared, this becomes plus 4x, this becomes plus 1. At this point, you could try to factor, it won't, so you could get out the quadratic formula. Again, I'm going to expedite the quadratic formula. Negative b is going to give us -4, plus or minus, we'll come back to the square root in a minute. The denominator is 2 times a is 1, so 2 times a is 2. Now let's go under the square root. B squared minus 4ac. B is 4, so b squared is 16. A and c are both 1, so 4 times 1 times 1 is 4. 16 minus 4 is 12. Oh goody, a number that we can't square root completely, but we can square root partially. Just a reminder about how to simplify the square root of the square root of 12. I can rewrite it as the square root of 4 times the square root of 3, and I know the square root of 4 is 2. So the square root of 12 simplifies to 2 times the square root of 3. And now we can split this into 2 fractions and reduce both. -4 over 2 is -2, plus or minus 2 square root of 3 over 2. The 2's cancel. We have the square root of 3. There's our remaining zeros. So the total list of zeros. The first one we found was the 1/2. We could have found the -1/2 first. The second one we found was -1/2. We could have found 1/2 second. And the other two are -2 plus square root of 3 and -2 minus square root of 3, which were not in our original list because they are not rational. Our list is possible rational zeros, Numbers like the square root of 3 or any decimal that never ends and never repeats is irrational. This pretty much wraps up the section. It's a lot to go through. This is one of the pinnacles of this class, how to solve big equations when you're not given any information in advance, which is sort of a lie because you are, thank you, rational zero theorem, but you have to go through a lot of trial and error to find a good box number that produces a remainder of 0 to knock it down a degree and keep going until you get to a quadratic, in which case you can solve it using those means. I do want to kind of let you in behind the scenes, so I'm going to remove the, this is a long, I told you this is going to be a long video. We're pushing 16 minutes. So I'm going to remove the camera from a tripod and plug it from the power source and just kind of show you what I do on the side prior to some of these problems. I already built something that was going to have a 0 of 1/2 and a 0 of negative 1/2. I built that from trying to set up something that would work nicely, and I ended up with wanting 2 plus or minus the square root of 3. This is the quadratic that gave that, and then I just multiplied it all out to get that. I did run through some bare bones synthetic division to make sure that one of the zeros worked. I did catch a mistake I made, but if we had unlimited time, I think I'm going to turn this around. If we had unlimited time, we could actually go through rebuilding polynomial functions based off of their zeros. For example, and I'm going to turn it around again. For example, if one of our zeros is this, negative 1/2, we could rebuild this factor as one of the factors. And if one of the zeros is 1/2, then we could rebuild it into this factor. It's not really that hard. How do we get that guy from those guys? It's not impossible, but I think it's a little bit beyond what I want to talk about. So we have one more section to cover in what is chapter 3 in the book. I know we're not referring to the sections by chapters. You can expect that homework to be up later this week. And that will be the end of test 3 material. Now, at the time of recording this, your test 2 is open for about another, what time is it? About another 8 hours. But by the time you see this, by the time it gets uploaded to YouTube, the test will probably be over. So hopefully you did okay and you sent me pictures of your work, because I will give partial credit if partial credit is merited. But you'll have a 3rd test coming up soon. We won't have a 4th test, but we will have a final exam, but I'll give you details about that in the future. I hope you guys are staying safe. I really am enjoying these videos, but the one thing I don't like about them is that they are monologues. We're not able to dialogue. You're not asking questions. Please feel free to contact me if you have questions on any of your homework problems. I can make an individualized video just to help you answer one of those questions. So don't be afraid to ask. Can't promise you an instant reply, but I'll do what I can. All right, you guys stay safe.